Assalamualaikum. I am Nurliana Shafika binti Muhammad Rosdi with ID number 2020820748 from AS 120217, Group 5. Today, my group and I will present about application of differentiation that includes differentiation and related rates, and also analysis of function 1 and 2 and their problem-solving question. We have 6 members in this group, which first, me, Nurliana Shafika binti Muhammad Rosdi, Muhammad Haris bin Muhammad Zudi, Nur Shafika Adawiyah, Nur Aina Faridi, Muhammad Izzat Sulaiman, and the last one, Nur Hana Najiha. So, let's go to the next step.
Now, we will see the meaning of differentiation. Differentiation, it is a process of finding the derivative or rate of change of a function. The practical technique of differentiation can be carried out by purely algebraic manipulations using 3 basic derivatives, 4 rules of operation, and a knowledge of how to manipulate functions. Derivative is used to determine the maximum and also minimum value of a particular function. For example, cost, strength, amount of material used in a building, profit, loss, and many others. Now we will see related rates. Related rates problem involves 2 or more variables that change at the same time but possibly at different rates. This usually involves writing an equation relating the 2 variables and taking the derivatives of the equation with respect to time. Related rates also use the implicit differentiation, and it's known for its benefits in the application of life. Now, related rate in the application of a real life is to figure out the speed of 2 vehicles that drive in different directions if each vehicle's speed and directions is unknown. The objective of related rate is to find the rate of change of one quantity knowing the rate of change of another quantity. To find related rates, identify the rate of change that are known and the rate of change that is to be found. Second, construct a formula or equation that relates to the variable in step 1. Differentiate both sides of equation, then substitute all the known terms or values given in step 3, and lastly, solve the unknown.
Okay, here is the problem statement for related rates. The question is, spherical balloons is inflated at a rate of 21 cm³ per second. So, we need to find the rate of change of the surface when the volume is 288 pi centimeter square. Okay, next. Okay, here is the solution for the question before. Okay, the formula for volume is V equal to 4/3 pi r power of 3. If we differentiate this volume, we get dV/dr equal to 3 bracket 4/3 pi r power of 3 minus 1 close bracket, and we get the answer is 4 pi r power of 2. Okay, and in the question, the value for volume is already given, which is 288 pi. So, what we need to do is we just need to substitute the value in this formula, and it will become 288 pi equal to 4/3 pi r power of 3. So, next, we just need to bring this 4/3 pi to this side and left the r power of 3 alone. Okay. After we bring the 4/3 pi this side, it will become 288 pi multiplied with 3/4 pi equal to r power of 3. Okay, this both pi we can eliminate this both pi, so it will become 72 multiplied with 3 equal to 72 multiplied with 3 equal to r power of 3. Okay, and we got 218 equal to r power of 3. Okay, this power of 3, we should eliminate this power of 3. Okay, which is we need to square root of 3 this value. After we square root this value, we get the radius is 6. Okay, next is a spherical balloon is inflate at rate of 21 centimeter cube per second. Okay, so we are having dv over dt equal to 21. In the question, we need to find the rate of the change of surface. So we need to find the dA over dt. Okay, the surface area is A equal to 4 pi r power of 2. If we substitute this area, we got dA over dr equal to 2 bracket 4 pi r power of 2 minus 1 close bracket equal to 8 pi r. Okay, next is we want to find the dA over dt. Okay, we try to formulate the dA over dt equal to dv over dt multiply with dA over dv. Okay, and we need to multiply the dA over dv first with dr over dv, and it will become dv over dt multiply dA over dr multiply with dr over dv. Okay, and we can see the dr over dv in this we don't have the dr over dv in this solution, in this question, but we have the dv over dr in this equation. So we can just take the dv over dr, and it will become 1 over dv over dr, and it's equal to 1 over 4 pi r power of 2. Okay, we have the, we just need to substitute the value that have in this question. We just need to substitute the value in this question, so it will become 21 multiply with pi and multiply with 8 pi r multiply with 1 over 4 pi r power of 2, and we need to substitute the radius that we got before in this question. So we got 21 multiply with 8 pi bracket 6 multiply with 1 over 4 pi bracket 6 power of 2, and the final answer is 7 centimeter cube per second. Okay, that's all from me. We proceed to the next topic. Thank you.
So I'm Maris Biomazi. I will talk about analysis of function 1. To find the rate of change of one quantity, knowing the rate of change of another quantity. Steps: identify the rate of change that are known and the rate of change that is to be found. Construct a formula or an equation that relates the variable in steps 1. Differentiate both set of equations. Substitute all the known terms of value given in step 3. Solve the unknown. concavity and inflection points. Fs more than 0, Fs is concave up on an interval if all of the tangent to the curve on below to the graph of Fs. Fs less than 0, Fs is concave down on an interval if all of the tangent to the curve on above the graph of Fs. Inflection point, a point on a curve where the concavity change from concave up to concave down. Analysis of function 2. Relative maxima and minima. Set a point, a point of a function which is a critical point but not an extremum, maximum or minimum. A high point is called maximum and a low point is called minimum. And general word for maximum or minimum is extremum. We say relative maximum or relative minimum when there may be higher or lower points elsewhere but not nearby.
Next, for the graph of polynomial function, on how to find the extremum point and inflection points. The first one is to find the function. Let function equal to 0 to determine the critical values. Find the critical line. Construct the first derivative table. Choose the correct sign. If the function is greater than 0, it will become the increasing interval. But if the function is less than 0, it will become the decreasing interval. Next, determine the extremum points. Find the function. Let function equal to 0 to determine the inflection values. Find the inflection line. Construct the second derivative table. Choose the correct sign. If the function is greater than 0, it will become concave up. But if the function is less than 0, it will become concave down. And the last one is to determine the inflection point. Next, for the asymptote. Asymptote is a straight line that a graph approaches without touching. There are two types of asymptote, which is vertical asymptote and horizontal asymptote. How to find the vertical asymptote? Is to let the denominator of a rational function equal to 0 and solve it. Then, find its analysis by approaching the values from the left and right hand sides. To find the horizontal asymptote is to find the limit of function when x approaches to infinity.
Problem statement. The x-intercept and y-intercept, vertical and horizontal asymptotes, fs inverse and fs inverse inverse, the interval where fs is concave up and concave down, the extremum point s and inflection point s. Sketch the graph of fs using the above information. For the first question, find s-intercept and y-intercept. To find s-intercept, y must be equal to 0, and to find y-intercept, s must be equal to 0. For the second question, to find the vertical asymptotes, first you need to take the denominator of the function and equal 0, then apply it to limit positive and negative for the function. Next, horizontal asymptotes. First, apply limit to positive and negative infinity for the function, and we will get y equal to 4. Then, if we get infinity over infinity, find the highest variables and divide it with all. For the next question, we need to differentiate them by using the chain rule. For ease, we consider the numerator as u and the denominator as v. The chain rule is when we minus the multiplication of u with v prime and u prime with v and divide them with v square. Then you will get the answer. The second derivative is when we differentiate the first derivative. For this chain rule, we need to bring the denominator beside the numerator and the power will change to negative. Then proceed with the differentiation process, then you get the answer. For the next question, to find the concavity, we need to take the second derivative and equal it to 0. After that, find the value of x. To avoid careless mistake, we need to do test table where it contains the intervals, test values, and the sign of second derivative functions. The test value could be anything based on the intervals and substitute it in the second derivative functions, then you get the answer. For the question number 5, it is extremum and inflection point. Find the first derivative of equation fs equal to 4s negative 1 per s minus 2 and s is 2. So interval increase at point 2 infinity and decrease at point negative infinity 2. For inflation point, we need to substitute 2 into Fs equation and inflation point does not exist. Thus, there's no extremum point. For the last question, sketch the graph. First, plot x and y intercept at the point negative infinity 2. The graph will be concave down, decreasing at point 2 infinity, concave up, increasing. Then make a dotted line of vertical asymptotes at s equal to 2 and horizontal asymptotes at s equal to 4.
As conclusion, for this topic, which is application of differentiation, we will be able to recognize the concept of difference based on primary principles, and second, distinguish between power function, identify some function stationary position using either the first or second derivative test, determine the nature of some stationary points, and the last one, understand and work with derivative in mathematical models as rate of change. So that's all from us. Group 5, thank you.